All right, in this video, we're going to just look at the concept of acceleration. So acceleration is basically saying how quickly you change your velocity. So cars can go from 0 to 60. That's a common way they measure how quickly cars can get up to speed. Let's say a car can go from 0 to 60 in 4 seconds. So the formula for acceleration is it's the change in velocity divided by the change in time, or the amount of time that it takes. So if it can go from 0 to 60, that is a change of 60 miles per hour. And that happens in 4 seconds. So if we divide these, we get the acceleration is 15 miles per hour per second. And what that means is that every second your foot is on the pedal, the car's velocity changes by 15 miles an hour. It changes at a rate of 15 miles per hour per second. So that is one acceleration. Let's look at another example. So here I drop a ball from a building or a tower, and if I drop it, it starts with a speed of 0 because it's not moving, and then it falls, and it's picking up speed as it falls, and over the course of 5 seconds, it goes from 0 to 50. So what is the acceleration? Again, acceleration is change in velocity over change in time. So the velocity changed, it went from 0 to 50, so that's a change of 50 meters per second. And that happened over the course of 5 seconds. So the acceleration is 10 meters per second per second. And in other words, for every second it is in the air falling, its velocity is changing by 10. So if I made a chart, time versus velocity, when it began, it had a velocity of 0. 1 second later, it was going 10. Another second later, it was going 20. Until after 5 seconds, it was going 50 meters per second. So 10 meters per second per second. Now the thing is, you're sometimes going to see this written as 10 meters per second squared. There's no real thing as a second squared. It just means meters per second per second. It's just like a shorthand way of writing this. So it means that for every second, its velocity changes by 10 meters per second. So don't get caught up in that squared thing. All right, so here's an object currently at rest, and it's accelerating over the course of 6 seconds. So if I make a chart, right now at time 0, it is at rest. It is not moving. And it accelerates at 2 meters per second squared. So remember, 2 meters per second squared means 2 meters per second per second. So 1 second later, if it's currently going 0, it'll be going 2. Another second later, it will gain another 2 in its velocity. It'll be going 4. And so if I continue this for 6 seconds, it'll be going 6, 8, 10, 12 meters per second after 6 seconds. So its final velocity would be 12. It accelerated at a rate of 2 meters per second per second. And there's a way to do this with a formula we'll get into later, but for now I just want you to understand the concept. Let's look at another. Here's a car moving at 40 meters per second, and it accelerates at -8 meters per second. So let's look at that as a chart. Time now 0, its velocity is 40. And if it's accelerating at -8 meters per second squared, that means its velocity changes by -8 meters per second every second. So 1 second later, it's going 32. And another second later, it's going 24. And a third second, it's going to be going 16, and then 8. And so after 5 seconds, it will have come to a stop. It'll be going 0 meters per second. So a car going 40, if it accelerates at -8, then in 5 seconds, it will have come to a stop. Let's look at one last problem. So here a car is moving -20 meters per second. So likewise, that means it's going to the left or the negative direction at 20 meters per second. So let's make a chart. It's currently going -20, and its acceleration is -5 meters per second per second. Every second, its velocity changes by -5. So that means 1 second later, it's going -25 meters per second. I subtracted 5, just like I've been doing. Second after that, it'll be going -30, and after 3 seconds, it'll be going -35. So here's the question. Is this car getting faster or slower? You might have seen the negative acceleration and assumed it was getting slower like the last example. But notice, first I was going -20, now I'm going -35. Well, -35 is going to the left at a faster speed. 35 is the speed. The negative just indicates the direction. So the car actually got faster even though it had a negative acceleration. So the big idea here is that a negative acceleration, does not necessarily mean that you're going slower. Sometimes it does, but sometimes it doesn't. It depends on the situation, and we'll look more at this later. But for now, that's just an intro to acceleration, so use this to help you figure out that introductory sheet, and we'll do more with it later. Until next time, I am Derek Genova. Have a delightful day.